Welcome to David Alexander Maths Tuition. This is chapter 13F, areas under the x-axis. Okay, so again this is like the final part of integration here. So let's just take a look at what's going on here. So sketch the following graph and find the total area of the finite region bounded by the curve and the x-axis. Okay, so if I were to set this equation to 0, I can factorise, so x plus 5, x plus 2 equals 0. So x is negative 5 and x is negative 2. So my curve cuts through at minus 2 and minus 5. So if I'm interested in the finite region, that is this area here. This is the finite region because on the other side, well, these lines will go on to infinity, so that'll be the infinite region. So this is what we're working out, and it's underneath the x-axis. In fact, I think I've prepared, there we go. So this is the area we're trying to work out here. So again, no major problem. All we need to do is integrate x squared plus 7x plus 10 with respect to x, and the upper limit is negative 2 and the lower limit is negative 5. So let's integrate that. So that's going to be x cubed over 3 plus 7x squared over 2 plus 10x, put that in square brackets, upper limit negative 2, lower limit negative 5. So that is going to be minus 2 cubed over 3 plus 7 lots of minus 2 squared over 2 plus 10 lots of negative 2 minus, so minus 5 cubed over 3 plus 7 lots of minus 5 squared over 2 plus 10 lots of negative 5. So let's work these out. So again, I'm just making life easy for myself by putting minus 2 into my calculator, hitting equals, and then just using the answer recall button. So that's answer cubed over 3 plus 7 answer squared over 2 plus 10 answer, so that is negative 26 over 3 minus, now I'm going to put minus 5 into my calculator and recall that with the answer button. So answer cubed over 3 plus 7 answer squared over 2 plus 10 answer, and I'm getting minus 25 over 6. Okay, so negative minus 26 over 3 minus 25 over 6, or plus 25 over 6, and what do I get? I'm getting minus 26 over 3. Now this is what happens when we are dealing with an area that is beneath the x-axis. The area is negative. Now of course you can't have a negative area, so we just need to ignore that minus sign. So this area here is positive 26 over 3 units. So just remember that when you're working out the area under the x-axis, expect it to be negative and then change it to positive. So here's another example. This is a cubic. So sketch the following graph and find the total area of the finite region bounded by the curve and the x-axis. So we need to find the x-intercept. So let's factorise this. If we were to make it equal to 0, we've got x squared minus 7x plus 12 equals 0. So factorise the quadratic, that's going to be x minus 4, x minus 3. So therefore the solutions will be 0, positive 4 and positive 3. So it's a positive cubic, so it's going to go up, down and up again. So it's going through the origin, it's going through 3, it's going through 4, so 0, 3, 4. Our cubic is going to look like that. So if I'm looking to work out the total area of the finite region bounded by the curve and the x-axis, I've got two areas, this one here and this one here. Now I need to do them separately. So, and bearing in mind, actually I think I've got a better sketch from Desmos here. So I'm going to work out this area first, and that will be between 3 and 0. And then I'm going to work out the area under the x-axis between 4 and 3. And remember, this area will be negative, so I just need to turn that into a positive. So first of all we need to do is integrate x cubed minus 7x squared plus 12x with respect to x. And that, first of all, that we're going to do that between 3 and 0. So that is going to be x to the 4 over 4 minus 7x cubed over 3 plus 12x squared over 2, so that's plus 6x squared. Okay, and that will be between 3 and 0. Now the good news is actually when I put 0 through this, I'm going to just be taking away 0. So that's one bracket sorted already. So actually not quite as bad as you think. So let's run 3 through the this equation. So 3 to the power of 4 divided by 4 minus 7 times 3 times 3 times 3 divided by 3 plus 6 times 3 times 3. So that is 45 over 4. So now I need to do exactly the same thing. So x to the 4 over 4, sorry, so 45 over 4 minus 0, that is this area here. So positive 45 over 4. Okay, so I'm going to do exactly the same thing. So 7x cubed over 3 plus 6x squared, and that is between 4 and 3. Now I know that when I put 3 through this, I get 45 over 4. So I need to subtract 45 over 4. So now I just need to put 4 through this. So 4 to the power of 4 over 4 is the same as 4 cubed. So 4 times 4 times 4. Take 7 times 4 times 4 times 4 divided by 3 plus 6 times 4 times 4. That is 32 over 3. And if I subtract 45 over 4, I am getting, my calculator is giving me negative 0.583. So if it was a fraction, it would be a pretty horrendous one. I mean, we could work it out as a fraction. So let's just do 32 times 4, which is 128. Take away 3 times 45, which is 135. Over 3 fours are 12. And 128 divided by minus 128, take away 135 and divide that by 12, I'm getting negative 7/12. Okay. So this area is negative 7/12, but it can't be, it's positive 7/12, so therefore the total area is 7/12 plus 45 over 4, so the total area is that plus that, and that comes to a total of 71 over 6. And again, you might want to just check the 45 over 4 and the 7/12 using the integration tool on your calculator just to check you've got it right.